There's a lot of tools and technology that we've heard about today, and I am, for one, really moved by the types of things that we can create. And I think what I want to talk about today is the types of tools that really fundamentally change the world. And I want to think about what it takes to build new tools from scratch. And I'm thinking about problems for our company at FabricNano around sustainable materials manufacturing. And in order to better understand how you would build a brand new tool, a fundamentally different tool, I'm going to take us back to the past. And of course, what you're looking at here is a railroad. And you've got an incredibly important tool in its time. This catalyzed an industrial revolution, and the trains and the transport networks still help us with our societies today to transport goods and services. But I want you to take a step back, and I want you to look at this as a set of tools that are comprised of those railroad tracks. I want you to think of those railroad tracks and what it took to manufacture these tracks. It wasn't easy at the time, and it wasn't straightforward to make miles and miles and miles of those tracks. And I want you to think about what would happen if I didn't use those tracks in this way. What if I, instead of laying those tracks down, were to use them in a different way? And while you hold that thought and you think about maybe another way you could use these materials, I want to introduce you to someone who had a profound impact on me and my life. And that, of course, is this man, Peter Cooper. Not necessarily a contemporary of mine, as you can see. This photo is very old. And Peter Cooper was around during that gilded age of railroads. Peter Cooper was a business tycoon, but he was much, much more. If you look at his face and you look at this beard, you must think Einstein, inventor, look at that thing. And you also look at the glasses and you see at least 4 lenses on those glasses. Peter Cooper thought of himself as an inventor. And during the time that he was around in New York City, in the early 1800s, 1850, New York City had a huge problem. There was just brick and mortar buildings, and people were building out and out and out, and they were running out of space. So Peter Cooper, of course, smartly, bought a lot of land. That's one thing he did. But a second thing he did was he heard about an invention called the Ibeam. The Ibeam was invented sometime in the 1840s in France, but it was having a lot of problems with manufacturing. And so what Peter Cooper did was he took his factory in Trenton, New Jersey, and he turned this factory into a production facility for this thing, which is called the Cooper beam. Now, if you thought about those railroad tracks and you thought about the prevalence of those railroad tracks during that time, you may have come up with this concept, which is essentially 2 different railroad tracks laid on top of each other and fashioned with a bolt. This Cooper beam was much easier to manufacture, and Peter Cooper sold lots of them into New York City to help with the construction of that city. A very simple tool, the I-beam, but incredibly important for modern cities and incredibly important at the time. This image probably pulls up a lot of thoughts for a lot of people. It is a very nostalgic image of men sitting on an I-beam constructing modern New York. And I love New York, I'm from New York, so this means a lot to me. But if you look at this image, there's lots of new tools here. There's a glass bottle that the man is using. There are gloves, there are boots. There are tools that we need in society to help build the modern world. And we will always need tools. We will always need new tools. But how do we build better tools? How do we take inspiration from Peter Cooper and work from first principles to build the things we need? Well, my relationship to Peter Cooper comes from this institution. This place is called Cooper Union. It's one of the first places to use a Cooper beam, and it's one of the only buildings of its time to be over 4 stories tall. In this institution, Peter Cooper set up, as a philanthropist, a place where you could study art, architecture, and engineering. Very first principles approaches to thinking about what human education should be. And it's at this place that I learned to hone a particular skill set, which is in engineering. And this is me as a 7-year-old. As a 7-year-old, I had an interest in engineering. I think we all do. I think people like to build tools. People like to build things. They like to tinker. And it's at this age that you can see a small plywood board there with a few nails that I found in my dad's garage. And when you put these 2 things together, you can make what looks like a pinball machine, and you get this incredible joy out of using these simple materials to build something more complex. But you don't know what you're building at the very beginning, and you're trying to just use fundamentals. And I really think that this is a fundamental problem we have today, which is we don't work back to fundamentals when we're scared. When we're scared of what the world is doing and what's happening, and we're scared of the climate crisis, and we're scared of the materials we overuse today, we run to solutions. And I don't want us to run to solutions. We got this incredible city, and there are many incredible cities around the world. London is now one of them. It is an incredible city in its own right. But this city that you're looking at from the financial district downtown is made of glass, concrete, steel. It's all possible because of the Ibeam. And would you have been able to conceptualize something like this if you didn't first work from the tools that allow these buildings to go vertical? Now that we've solved that problem, we've got an overuse of petroleum-derived products. There are 8 million people in this city, all using iPhones, plastic bottles, transportation of packaged goods. Amazon is rampant in this city. I'm absolutely sure of it, because I hear from my friends that everyone is using Amazon. But there are fundamentally problems in the way we consume materials. There are lots of us. It's not just these 8 million people, it's 8 billion people. We have about 8 billion metric tons of plastic that have gone into waste since we invented those materials over 50 years ago. There are 8 billion of us on this planet today. That's about a metric ton of plastic per person. We're about to hit 10 billion people on this planet, and they're going to live like people in New York City. They're going to consume more and more materials. And so we know that we need to solve this, but we're very anxious about it. We want a tool quickly. We ran to these things. We took the oldest technology we knew to make something like a bioplastic. We ran to yeast. Yeast everyone is familiar with. This is a brewery here. Yeast can take sugar and make alcohol. Great. Biology-inspired materials. Let's try to get that yeast to produce bioplastic. And so in the early 2000s, what we call Clean Tech 1.0, we ran to throw biology, as we misunderstood it, into these reactors to try to make materials we know we needed, biology-inspired, but not understood. And we spent billions of dollars trying to make things like bio-based plastics, but we failed. We failed because you do not see bio-based plastics supplanting petroleum-based plastics. That is not the case today because the cost points aren't right. And I would argue that if you really wanted to go after bio-based materials, you should have gone back to this. This is a protein. And proteins are the most incredible machinery that we have to build new materials today. Where do we use proteins? Where do we see proteins? Well, proteins are involved in this forest. Every tree leaf you see, every living system has protein in it. So the forests are made of protein. They're literally produced from the protein. All the material comes from protein chemistry. That gorilla you see, it has a lot of the same genetic code as you and I. It shares a lot of the same DNA. But that gorilla looks like a gorilla and is transcribed to have the material properties of a gorilla because a protein read its DNA and decided, I'm going to make a gorilla. A lot of what happens in biology is governed by protein. And the hair on the gorilla is governed by protein. That material comes from protein. The cuticle of an animal comes from the same sets of proteins, but producing different chemicals. That seashell, which has its rigidity, it comes from proteins that do chemical production of things that are rigid. And so I ask, why are we not using proteins to produce materials? And when we started FabricNano over 4 years ago in 2018, what we saw was there were applications of people using proteins. What we currently make from proteins is very limited. We can use protein without living systems, and we can use this fundamental element, this protein, to make high fructose corn syrup. Every single kilogram of high fructose corn syrup on the market today is made from protein. Just one protein that converts glucose to fructose. It's a very simple thing to do. There are over 15 billion kilograms of high fructose corn syrup sold every year. Another single protein that we're all familiar with now, maybe has a better rap than the high fructose corn syrup, is a polymerase chain reaction caused by something called the polymerase protein. If you recognize that acronym, PCR, the PCR test relies on a single protein, which is capable of taking DNA and making more material DNA. And if you see a lot of material DNA, you know you have the virus. Single proteins are an application today. And as we have heard from companies like DeepMind in London and programs like AlphaFold, we are getting a better understanding of how to build proteins. what the functionalities could be from these proteins. So I ask, why are we not using proteins? Why are we not going back to those railroad ties, those railroad tracks, and building better technology from fundamental components? Why are we not taking a first principles approach and working with proteins to make materials, to make bioplastic? And so this is exactly what FabricNano is trying to do. At our company, we are taking a set of proteins, and we are assembling systems of them that are capable of going from any input to any output. Proteins have more control over the material world than anything we know of today. Biology created them, and it can inspire us to build better production systems for bio-based materials. So at FabricNano, we are taking those deconstructed pieces, and we are assembling what looks like the biological processor to enable all of the biomaterials that we need. And so at our company, we think a sustainable future is possible, but it's powered by protein. It requires us to take a step back to understand the tools that exist in biology. And when we understand those tools, we can build a better future together, and we can build better products. And so I am under time, which is a great thing for a conference running behind time. And I would love to take questions from the audience, and I hope we have a few. Thank you guys very much.